All right, guys. Hope everybody's hanging in there. We're getting ready for our second week of e-learning. I don't know about you all, but I'm getting really bored. I'm usually a homebody anyway, so being home's not that big of a deal, but not having the option to go out and do something, the mall, the zoo, the movies, whatever. I don't know, it's just getting kind of old. So hopefully all this stuff is going to blow over soon and we can start kind of getting back into a normal routine, whatever that might be for us. All right, so today we're going to start inverse relations and functions, and this is probably going to take us a couple days to get through. All right, so inverse relations. First, I want to talk about what a relation is, and we learned this, I don't remember, maybe the second 9 weeks. It might have even been the first 9 weeks. It's been a while, though, since we've talked about relations. I think it was in the second 9 weeks. All right, so a relation, if we remember what a relation is a function, which is just an equation. Remember, function and equation is kind of the same thing, where each x value, remember we call the x's domain, so each x value are our domains, goes to one y value. And remember, our y's are called our ranges. And if you remember, I kind of used the analogy boyfriends and girlfriends, and that boyfriends can only have one girlfriend. If you remember, we talked about it like that. All right, so there were 3 different types of relations, and the way that you can see them. 2 of them are yeses, and one of them is a no, as far as whether it's a function or not. All right, so also remember, relations can be given to you as a table of values, coordinate points. It can be given to you on a graph where you have to get the coordinate points. I think there was one more relation that we talked about, and I can't remember what it is. All right, so I have 3 different relations. On the table of values, here's my x's, here's my y's. Remember, your x's are your domains, your y's are your ranges. I have them labeled. I didn't do this one because I ran out of room, but I labeled them for these 2. So my x and y, so I have 3, 6, 4, 7, 5, 8 for my x and y. And if you notice right here, I actually wrote them in coordinate points. We learned how to do that before, and this is going to be helpful if you have to turn them into a graph. Okay. Now this is a yes because 3, 4, and 5, they only appear each once. So all of my x's are different. So anytime all of your x's are different, they're automatically going to one y value, then that's an automatic yes. It's a function, okay? All right, on this one, same thing. Oh, I forgot to put my y right there. But this is my x's, this is my y's. I made them into coordinate points. Now, if you notice, my 3 does repeat. But if you look at the y values, the 6's repeat with it. So as long as the x's and the y's repeat, then it's still a yes, it's going to be a function. Okay. All right, on this last one, this ends up being no, not a function, because my 3's repeat, but my numbers on this side are different. One is a 6 and one is a 9. So this is an example of boyfriend 3 going out with girlfriend 6 on one day and going out with girlfriend 9 on another day, right? The 3's can only go to one value. And we talked about if you were to plug that 3 into an equation, it's not going to give you a different value the next time you plug it into the same equation. It should stay the same. So that's why this would be no, not a function. I just remembered the other way we did was the vertical line test. If you remember, we had to draw that vertical line to see how many times it crossed the graph. That was our other test we did. All right, so that's just normal relations. What we're going to talk about today is an inverse relation. An inverse meaning not exactly opposite. I don't want you to think of opposite, but inverse means like reverse the order is basically what you do. So you reverse the order of the x and the y values, like you physically change the order that they're in. Okay, so you don't change the signs. If they're positive, they stay positive. If they're negative, they stay negative. But you reverse the order. So here's my original relation. I got another one down here. Okay, so 2, 4, 6, 8 are my x's. 1, 3, 5, 7 are my y's, and I put them in coordinate points. To get the inverse relation, my x and y stays where it's at, but I physically change the order of the numbers. So it went from 2, 1 over here, 1, 2. 4, 3, went to 3, 4. 6, 5 went to 5, 6, 8, 7 went to 7, 8. Like I physically changed the order that they were in. That's all you do. And then what I'm going to do next is I'm going to graph both of these sets of points on a graph so you can see. So that doesn't look all that different, but you can see how they do graph differently because of the order that they're in. And it doesn't look too different just because these are straight lines. If I had maybe made a graph that involved like a U or a V shape, you might be able to see a little bit of a difference. So these are those same points. This is the original relation, and I graphed it in red down here. So 2, 1, 4, 3, 6, 5, 8, 7 were the points. And remember, you got to walk to the elevator before you can go up. So I got to go to the right 2 and then up 1. So there's 2, 1, right 4, up 3, right 6, up 5. And then my graph wasn't big enough to do this, the last one, 8, 7. All right, so that's the original relation. Let's do the inverse relation. So remember, we just switched the order of the points. So 1, 2 is right there. 3, 4, 5, 6. And again, I ran out of room. I can't do the last one, 7, 8. So to look at it, they are kind of like mirror images of each other. Even though they're straight lines, it's hard to tell. Like I said, if I had done a U shape or a V shape or something, you might be able to see more of a mirror image of them. But these are literally just flipped. That's all they're doing. Okay. So on your assignment today, most of the questions are: is this a relation? So you just look. You look at the two sets of numbers. Are they opposites? Not opposites. I don't want to say opposite. Are they reverses of each other? If they're reverses of each other, like down here, these are reverses, and you say yes, it's a relation. If they're not, or yes, it's inverses. I mean, if they're not, then you would say no. Or it might want you to actually pick out a point that makes it an inverse. So you just look at your answer choices and pick out one of the coordinate points that is in reverse order. All right, so hopefully everybody's doing well. Remember, you can email me or text me if you have any questions about anything. I'll see you guys tomorrow.